Alright, this is section 10.3, rational equations. Corner seats, move your chairs please. Take out your highlighters. Tonight's homework is page 630. Really guys? Really? It is actually a very short assignment because I want to make sure that you get all of them right. So I want to do as many as I can with you today. That way you feel good about solving rational equations. Dylan, that should say rational equations. Can you change expressions to equations? What's the difference between an expression and an equation? Guys, what's the difference between a rational equation and a rational expression? What's in the word equation? It's an equal sign, right? So if there's an equal sign, you know it's an equation. If there's no equal sign, then it's an expression. Mina, I'm waiting for you to move your chair. All right. We're going to be dealing with equations. So we're going to be dealing with expressions that have equations in them. There's an equal sign in them. Okay? So let's say I have example 1. 2x over 3 plus x minus 2 over 5 equaling 6. I'm going to show you multiple ways to do these types of questions. And it's going to be your job to watch the videos and to decide what you like best. There's going to be more than one way to do these types of questions. Either way, you need to decide what works best for you, but you're not going to be able to do it just watching me do it one time. So what I'm going to do for the first method, I'm sorry, it's not equal to 6, it's equal to 1/6. My bad. So I want to find the least common denominator for 3, 5, and 6. That means I want to find a number that all 3 of these numbers fit into. 3, 5, and 6. And that number is going to be 30. So what I'm going to do is I'm essentially going to multiply each of the fractions by 30. So I'm going to take this 30, multiply it by 1/6, take that 30, multiply it by x minus 2 over 5, take that 30 and multiply it by 2x over 3. So what I'm doing is this. I'm taking each one of these terms and multiplying them by 30. So it's 2x over 3 times 30, x minus 2 over 5 times 30, 1 over 6 times 30. Now if you put this over 1, you can reduce it to this 30 and this 3. 30 divided by 3 is just 10. So then this first term becomes 10 times 2x, which ends up being 20x. Same thing here. If I put this 30 over 1, this 30 and this 5, 30 divided by 5 ends up being 6. So this second term becomes the 6 times the x minus 2. And that equals 30 times 1/6. Again, you put that over 1. 30 divided by 6 is just 5. So one way to get rid of the denominator is by multiplying by its least common denominator. So what did I do here? Multiply both sides of the equation by the LCD. And that's going to get rid of your fraction. So now, this right here, much more pleasant to deal with. All I have to do now is solve for x. So I have 20x plus 6x minus 12 equaling 5. That's 26x minus 12 equaling 5. That's 26x equaling 17. So x equals 17 over 26. Questions on example 1? All right, example 2. Sometimes it's not easier to find the least common denominator, but I'm going to show you another example of using that same method. So let's say I have x plus 3 over x plus 2 equaling 1 minus x plus 1 over x plus 2. So this is the same thing as 1 over 1. I want the least common denominator for x plus 2, 1, and x plus 2. So if I use that same method, what does the list say there? I'm going to multiply everything by x plus 2. Actually, the Valentine's and then I'll go over that other stuff. So I'm going to multiply everything by x plus 2. And watch what happens. So I'm going to do x plus 2 times x plus 3 over x plus 2. That's the first term. Now x plus 2 times 1 minus x plus 2 times x plus 1 over x plus 2. This is the same x plus 1 right here. I'm sorry, x plus 2. This x plus 2, that x plus 2, that x plus 2. It got distributed. Alright, let's do one at a time. What's x plus 2 times x plus 3 over x plus 2? What's going to happen to the x plus 2s? Going to cancel. And that's the whole point of why we're doing this. If you multiply by least common denominator and it doesn't cancel, you are literally making more work for yourself. That's the whole point, is for you to get rid of the denominator. So here I'm just left with x plus 3. Equaling, well, what's x plus 2 times 1? It's just x plus 2. Minus, these cancel and you're just left with x plus 1. There's a minus sign here. Some of us are still making silly mistakes with that minus sign, but you do need to distribute that negative. So we have an x plus 3 equals x plus 2 minus x minus 1. These x's are going to go away. I'm left with x plus 3 is equal to 2 minus 1, which is just 1. So x is equal to, subtract 3 on both sides, a negative 2. There's a problem here, though. Look at my answer. If I plug in negative 2 here, what happens to my denominator? Are we allowed to have 0 as a denominator? No, right? So my answer mathematically, x equals negative 2, but when I plug it back to the equation, it's going to give me an error. So the reason why I wanted to show you this is that we have to get used to correctly processing our equation by verifying the solution, okay? Since x equals negative 2 gives me an extraneous solution, it's what we call extraneous. God bless you. This problem has no solution because the one solution I found actually doesn't work because it makes my denominator 0. So we have to plug them back in to see if it makes my problem actually have no solution. more example, and we'll do a doyo. It's gonna go under the microwave. There's a box that has Valentine's Day stuff. You're gonna put it in there. So I have x plus 3 over x plus 2 equals 2 minus x plus 1 over x plus 2. Very similar to what we just did. Kaya, what's going to be my least common denominator they're going to multiply everything by? Kaya. Yep, good job. So I want to multiply everything by x plus 2. Kirsten, are you with me good? Are you good? So for those of us who have a hard time seeing this, I would recommend writing this in color, so you know you're going to do x plus 2 times the first term, x plus 2 times the second term, x plus 2, however many terms there are. So it's x plus 2 times x plus 3 over x plus 2, equaling x plus 2 times 2 minus x plus 2 times x plus 1 over x plus 2. Daisy, help me out here, babe. What happens here? Cancel. You're left with? Mina, what happens here? Mina? Distribute. What do you get? Yep. And Dylan, what happens here? What cancels?
X plus 2, x plus 2.
And what are you left with?
X plus 3.
Almost.
Negative x plus 1.
Minus x plus 1. Good job. Elizabeth, what should I do with this minus sign? Absolutely. Don't forget to distribute. Sean, isn't it under the microwave bin? Okay, just put it in. That's good. Alright, so I have x plus 3 equals 2x minus 4 minus x minus 1. Combine like terms, we got a 2x and a minus x. We got a negative 4 and a negative 1. What did I do? Oh, thank you. Thank you. So I have an x plus 3 equals 2x minus x, which is just x, and then positive 4 and a negative 1. Positive 3. What? X plus 3 equals x plus 3? Alright, let's see what happens here. Subtract x, I get... What happened? What happened to our x's? Doesn't this become 0? And then minus 3 and minus 3, what do you get? 0. When is 0 equal to 0? Just today? Always, right? Always. 0 is always going to equal 0. So that means that this problem has infinite solutions. Does this look familiar? Remember we used to do systems of equations? And we used to have infinite solutions and no solution? Whenever you have both sides of the equal sign giving you the same exact number, 0 equals 0, 1 equals 1, 14 equals 14, a million equals a million, then you have multiple solutions, infinite solutions, except there is one solution that's not allowed. Don't yell it out. What is it? What is x not allowed to be? Ready? What is x not allowed to be? Negative 2. Very good. Why? What would happen if your answer is negative 2? Yeah, it would make your denominator 0, which would be undefined, right? So it can be any number in the world except negative 2. So it isn't really infinite solutions. Basically, it's all reals except x cannot equal negative 2. How do you write that in set notation? Negative infinity to to -2, and then negative. Well, 2 is okay. Good job, babe. This is how you would write it in set notation. Here's your doya. Four over x plus 1 plus x plus 5 over x plus 1 equaling 5. Josh, what did you multiply everything by? Yep, so you multiply everything by x plus 1. Boom, boom, boom. Brooklyn, what happens when you multiply to x plus 1 times 4 over x plus 1? Thank you.
Oh, they cancel out.
They do cancel. And what are you left with?
4.
Just 4. Plus,
X plus 5.
what's left over here, Mia? What's x plus 1 times all this? What happens?
They
Yep. And what are you left with?
5.
Almost.
X plus 5.
Yep. Equals the right hand side. Angela? What do you get on this side?
5x plus 5.
All right. Heidi, what do you get on the left hand side now?
X plus 9.
X plus 9 equals 5x plus 5. Destiny?
Subtract equals
Uh-huh. You get 9 equals?
So 9 equals 4x plus 5.
Mm-hmm.
And then subtract 9. And then 4 equals
4x equals 4, so x equals?
Wait.
Is that right?
Oh.
What do you think, Isaiah? Pretty easy? All right. What would this have to say? Please write this down with me. What would this have to say if it was no solution?
Negative.
It would have to say what? If this said x equals -1, yeah, no solution. Everybody with me? But it doesn't say that, so it's not no solution. What would it have to say if it said infinite solutions?
0.
Like 0 equals 0, or 1 equals 1, or x equals x. All of those give you infinite solutions. We're not getting rid of it. This is the final answer, babe. Okay, so let's not be confused. Yes, this is right. We're done. Oh.
X plus 9, how did you
Subtract x, honey. See it? Okay. Good question. But some of us get like no solution happy, if I can say, or infinite solution happy. Like you want to make everything no solution, or everything not, or everything infinite solutions. These are actual special cases. Only if it says the denominator equaling to 0 or infinite solutions. All right, one more thing that I do need to add to no solution. Everybody needs, don't let me lose you on this part. If you get all the way down to your equation and it says something like 4 equals 5. When is 4 equal to 5? When? What day of the week? Never, right? 4 is never equal to 5. If you get down to this type of problem, then it's also no solution. So these are the cases of when it's infinite or no solution. Can you guys please put that in the highlighter so it stands out? I don't want you to forget. All right. What if I'm asking you if something is a solution to something? So let's move on to example 4. Is x equals -3 a solution to this problem? If this was a test question, I don't want to do this with you yet. I want to get at least 3 ideas on how you could do this problem. How would you do this problem to see if negative 3 is a solution? When you're ready, raise your hand. 1, 2, 3, 4, 5, 6, 7, 8. 9. 10 seconds to your group, talk to each other. How would you do this problem? How could you figure out if it's a solution?
Plug in the negative into the equation, right?
Sean, what do you think, babe? So say that louder. Yeah, so Jashawn is saying, why don't we plug it in? Let's plug in negative 3 right here, plug in negative 3 right here, plug in negative 3 right here, and see if they're actually equal to each other after you plug it in. Allie, what's another way to do it? Jeannie, anybody? Solve for it, just like we did in the first few examples, right? You can multiply by its common denominator, right? And solve. Right, Josh? How about the old school way? Does anybody recognize something we could do? I'll use my hands.
Cross multiply.
Yeah, we cross multiply. So that's 3 different ways that you could do it. Okay? Alright, if you're in seat A, I want you to plug in x. Plug in x equals negative 3. That's what I want you to do. If you're in seat B, I want you to use the LCD like we just did in the first 3 examples. Like examples 1 through 3. If you're in seat C, I would like for you to use cross multiplication. And if you're in seat D, you get to choose one and see which of the 3 you prefer to use to find out if it is an actual solution. I'll check in with you in about 15 seconds. So what's the least common denominator for both of these? A 4 and a 1 minus x.
Okay, so then do I distribute 4 into 1 minus x? So when I multiply it?
You can, yeah, you can. Do you see how much more work that is? That's what I want you guys to realize now. Is sometimes LCD is bomb, one step. Some you're like, I'm just gonna plug it in. And some you're gonna cross multiply. But I want you to realize that like this right here, LCD is not gonna be the smartest thing to do.
It's not. It's a no.
You guys, out of the 4 methods, 3, sorry, which of the 3 works best for example number 4?
Plug.
Plugging it in, okay? Plugging it in is probably going to win just as many votes as cross multiplying, because some of you guys don't mind cross multiplying, but then you get right here and you're like, oh man, I got a FOIL. Not a problem, you could, but the most efficient, by far, the most efficient matter is going to be using plugging it in. Everybody with me? What's the least one? Yeah, LCD. Look at LCD. You got 4 and a 1 minus x, and you're going to have to do multiply on both sides. It's just not fun. Okay? But answer the question. Dylan, is it a yes or no?
No.
It is not a solution. Alondra, what'd you guys get? Yes or no? No. What'd you guys get, Michaela? No. When you guys plugged it in, and I think Dylan is your seat A, right? What did you get when you plugged in on the left-hand side?
Well, it's 7 over 4.
7 over 4, right? And then on the right-hand side?
Negative 7 over 4.
And that's definitely not the same thing. Right? Negative 11 over 4?
Yeah, negative 1. Yeah.
It's not negative. It's negative 11.
Either way, right? Definitely a no. So if I ask you, is it a solution? The answer is no. Not a solution. Sorry. Sorry, Daisy, it fell asleep. Hold on, sorry. Here's your doyo. Is x equals 4 a solution to 5x minus 8 over 2x minus 8 equaling 20 over x squared minus 16. And you should already be done. You know why? I'm not gonna tell you why. I'm not gonna tell you why. Why should you already be done? Tell your group.
So you do like 8 minus 0. Oh! Zero equals 0. Isn't it an infinite solution?
But is your 0 allowed to be in the denominator?
Oh, no.
Thank you, Daisy. Victoria, is 4 a solution? ¿Por qué? ¿No quieres decirme en español? Go ahead, just kidding. What equals 0? What happens when you plug in 4, girl? Yeah, the denominator is equal to 0. Is that allowed, Elizabeth? So what happens if the denominator is equal to 0? Then there's no what? There's no solution. But I'm asking you, is 4 a solution? I'm asking you, it is a solution? Raise your hand if you say if 4 is a solution. You just said yes, homie. Raise your hand if you say 4 is not a solution. Makayo, tell Elizabeth why. Elizabeth, he's telling you. Okay, again, is 4 a solution? Why not? It makes your denominator equal to 0. And that's not allowed. Okay? So the answer to the doyo is no. Tonight's homework, you are going to be using method C, which is cross multiplying. That's going to be the one. You don't have to, but I'm letting you know this is going to be the easiest one. You can do whatever you want. And you're going to see that I should have just done that. Okay? Let me show you why. Take out tonight's homework, guys. You don't have to, Garrison. You can do whatever you want. But if you're comfortable, use the LCD. But I want you to be able to use both. Because we've been doing this all week. So I want you to be comfortable with cross multiplying.